Hello everyone, greetings to all. I am Dr. Vijaya Kumar, Assistant Professor in the Department of Mechanical Engineering, JJ College of Engineering and Technology, Tiruchirappalli. I am going to present the topic additive manufacturing. Additive manufacturing is the advanced manufacturing technology. Currently it is working under the Industry 4.0 and Industry 5.0 as well. So prior to that, we should know about the what is manufacturing. So manufacturing is nothing but the process of converting raw materials into full product. So it has some types like casting, forming, machining, joining, and additive manufacturing. So first one is casting. Pour a liquid molten metal into the mold cavity to required shape and size of the part for waiting some time for cooling as well as the solidification, and finally we can get the obtained part. So this is called the casting process, and the next one is forming process. So the sheet material is strained by punching a force into a bent shape, usually in a straight axis. It can be able to create a V bend and U bend as well as the and cup shape. We can able to create it by using this forming process. And the third one is machining. The machining process is nothing but we just remove the unwanted material to create a actual product from the raw material. So it may be the small chips or maybe the chipless for obtaining this type of machining process. From this figure, we can see this first one is the turning process, and the second one is the drilling process, and third one is the milling process. Some other process also available like planning, slotting, sawing, filing, shaving. So these type of all processes are come under the machining processes. And the fourth one is joining. The two or more similar or maybe the dissimilar materials we can able to join or combine together to create a single piece by using this type of joining process. So these four processes so far we can classify by this under the classification of conventional or maybe the traditional manufacturing processes. And next, additive and subtractive manufacturing. Now we should able to the additive and subtractive manufacturing differences. The first one is we just take the subtractive manufacturing, which means so just take a solid part, then do some of the machining processes. We have already mentioned some of the four processes. If suppose we can implement any one manufacturing processes, that means subtract the material, we just remove the unwanted material from that bulk piece. That is comes under the subtractive manufacturing. And the next one is the other case additive manufacturing. That means we just create some of the powder particles. It may be the polymer or maybe the metal powders. So based on the material, we just add the material in layer by layer manner. So we just see some of the differences between these two processes. First one is in subtractive manufacturing. So after getting the final part, the more number of wastages we can see that. But instead of this additive manufacturing processes, in additive manufacturing process, less waste only we can able to observe. So this is the main difference. So simply we can say about this subtractive as well as additive manufacturing means, subtractive means just remove the material from the bulk piece. In additive manufacturing, we just adding the material in layer by layer manner. So this is the major difference between this subtractive and additive manufacturing process. The definition of additive manufacturing developed by the ASTM standard is nothing but the additive manufacturing is the process of adding the materials in layer by layer manner from a digital 3D CAD model. So it also known as 3D printing, layer manufacturing, and solid freeform fabrication. From this figure, you can able to see the every layer of this entire product. So this is the addition of layer materials. So finally, this process comes under the additive manufacturing. And this is the additive manufacturing workflow. So first, we just determine the object. So which part will able to create it, that one is, we should identify that. First one is determine the object, then create a design by using the 3D modeling software, maybe the SolidWorks, CATIA, or some other softwares. By using that software, we just create a design, 3D model design. Then the design should be import into the slicing software. So for in STL format, so this slicing software able to create it as a generating G codes. So the slicing software like Simplify 3D, Cura, and some other software also available. So finally, after slicing the 3D model, Next, the file transfer into the printer. So from the printer, before take a printing, we just find the feedstock. Feedstock is nothing but the raw material. So the raw material, we need to choose it because the raw material is in a different form, maybe the filament or wire form or maybe the powder form. So afterwards, we just import into the printer in the same 3D model as well as feed the material. So next, the printing will start. So after printing, we just remove the model from the printer bed. So then we need to do some of the post processes because many of the additive manufacturing processes has some of the post processes. So the post processing means if suppose we are creating a metallic product means we need to do some of the heat treatment process or maybe the machining processes. So these are all comes under the post processing method. So after completing the post processing, we can able to see the application oriented part. It's just like a end use part. Okay. So these are all the overall workflow of the additive manufacturing process. And next, why this additive manufacturing is required, which means some of the traditional manufacturing process has some problems. They are high tooling cost. Tooling means we need to use some of the mold or maybe the jigs and fixers, some of work holding or tool holding devices are required. But in this additive manufacturing process, there is no tooling. So this is one major drawback in that traditional manufacturing process or subtractive manufacturing process. And long lead time. From the beginning and ending time is very crucial for any manufacturing process. So it takes more time. And next, limited customization, which means the individual needs we are not able to fulfill it by the traditional manufacturing process. In additive manufacturing process, we can able to create a number of customized products. And the material wastage also is high compared than additive manufacturing process. And the complex design limitations, some of intricate parts is not possible by developing by the traditional manufacturing process. For the additive manufacturing process provides some of the faster production and less waste, mass customization, lightweight structure. In this case, additive manufacturing process also has some of the limitations, especially this additive manufacturing process is mainly used for the mass customization, not for mass production. But in this traditional manufacturing process, we can able to prepare the mass production. So this is the major drawback in the additive manufacturing process. And some of the evaluation of additive manufacturing technology is available from 1980s to today. So now we are meeting the industry 5.0 by using this type of additive manufacturing technology. So these are all the main evolution by the additive manufacturing technology. And some of the historical timeline also is available in 1980s to in future to 2030. So it is for developing of the SLA, FDM, SLS, the different technology has evolved by this historical timeline. And the main 4 stages of developing additive manufacturing process. First one is rapid prototyping, then rapid tooling, next rapid manufacturing, finally in additive manufacturing. So we'll see in the upcoming slides what do you mean by rapid prototyping, rapid tooling and other cases. So for the rapid prototyping, rapid means just quick. So we can able to quickly produce a physical prototype which is called rapid prototyping. So by the of the additive manufacturing technology, we can able to create a prototype in speed. So mainly it is for the purpose like verify the concept and visualize the product. Also the design testing, we can able to just implement this type of purpose. We can choose this type of rapid prototyping. Also some of the advantages and applications. Mainly the applications of this rapid prototyping means, suppose in IC engine model, we just cut model or cross-sectional models, we can able to easily manufacture or fabricate by using this type of rapid prototyping technology. Mainly the prototype is just a physical model. So this prototyping is developed by this cut section of IC engine, able to create it. Okay. And next, rapid tooling. So tooling is nothing but just if suppose we are going to prepare a part by the traditional manufacturing or conventional manufacturing process means, at that time we need some of the mold, die, jigs, fixers, this type of extra materials are required. But in this case, the rapid tooling, We are also able to easily fabricate the tooling. Tooling means like molds, dies, jigs, fixers, and tooling components also we can able to create it by this rapid tooling technology. And the main types like direct and indirect tooling. Also the advantages reduced tooling cost, because the traditional manufacturing has we need to spend more cost for the tooling purpose. In this case, reduce the tooling cost and also the short production cycle. The rapid manufacturing, the production of manufacturing part for the functionality and also the end use part, we can able to create it by the rapid manufacturing by using any one additive manufacturing technology. And the characteristics, we have already discussed about the characteristics in tooling is not required for this additive manufacturing sectors, and high accuracy, customized production is possible, and also low volume manufacturing. In this case, we just create minimal product only we can able to develop by this type of rapid manufacturing. And also the examples, aircraft brackets, medical implants also developed by this rapid manufacturing. And the additive manufacturing is classified in 7 major categories. It is also covered by the ASTM ISO 52900 standard. First one is material extrusion, second one is VAT photopolymerization, third one is powder bed fusion, and fourth one is binder jetting, fifth one is material jetting, direct energy deposition, and sheet lamination. These 7 major categories also has some of the separate processes, additive manufacturing processes are available. We will see about this type of technologies one by one. In this case, first one is material extrusion. For this material extrusion technique under the additive manufacturing technology, the processes like FDM, triple F, that means fused deposition modeling, fused filament fabrication. So the working principle, just thermoplastic filament only possible to develop as a end product. We just the filament is a feedstock material fed into through the heated nozzle, which is connected by the extruder. The filament melt and is deposited in layer by layer manner. So the each deposition layer cools and solidification before the next layer is added. Okay, this is the main working principle. And materials we have used PLA, ABS, PETG, and some other carbon fiber material also use. Nowadays, some of the metal filament also is available, and by using this type of material extrusion technology, so metal products also developed. So this is some of the schematic diagram of this material extrusion technology, and the video is available for this developing a end product as adding layer by layer. The next technique, VAT photopolymerization. Under this VAT photopolymerization, stereolithography apparatus and digital light processing, this type of processes are consist from this VAT photopolymerization technique. So the working principle of VAT photopolymerization is one VAT container is available. On that container, we just pour the liquid resin. So the first case, we have seen the material extrusion technology. The technology, the filament is in the form of wire or maybe the filament, but in this case we just using the material in the form of liquid resin. Okay, so that resin cures by the UV light. Okay, so wherever the material is processing, so the liquid resin flowing that model, and that model we just the UV light passed on that model, that particular place is only cured by the UV lights. So the platform moves after each cured layer, and also the process repeats until the part is complete. It may be the top to bottom approach or bottom to top approach by using this type of SLA or DLP processes. So the materials, standard resins and ABS or PLA type of resins are also used, and some of the elastic resins and engineering resins and biocompatible resins also is available for medical applications. So this is the schematic diagram, and the actual part how developed by this type of DLP or SLA technology, and that figure is available in top. And the third one is powder bed fusion technology. The most of the metal products are developed by this type of powder bed fusion technology. Here more number of processes are available, like selective laser sintering, selective laser melting, direct metal laser sintering, and electron beam melting. These are all the major processes come under the powder bed fusion technology. The working principle of this technology is the powder material is spread on the single layer, fine thin layer. Similarly, the laser rays are passed on wherever the product is available. The laser rays are passed on that particular places. Then finally fused to the material and also get the complete part. So the every layer add one by one. So finally we can get a single physical product. The materials like titanium, aluminum, stainless steel, Inconel and Invar, so more number of materials, especially the metal materials are prepared in this type of powder bed fusion technology. And the next one is binder jetting. For this binder jetting, you just use the color jet. Color jet means the same powder particles are layer by layer formed on that process. Afterwards, the binder jet focused on that layer. So finally, to solidify the condition, so afterwards we can get a proper metallic product. Here also the sand, metal and ceramic materials are used for this binder jetting technology. And next one is material jetting. Here also the same, the material is through the jet, get deposited on the bed. So here also the photopolymer cures on that materials. So on that bed, here also the materials used photopolymers like plastics, wax, metal particles are also developed by using this type of material jetting technology. And direct energy deposition, laser engineered net shaping, this process is mainly used under this direct energy deposition technique. So in this technique, metal powder or metal wire is used for developing a product. So uniquely this technology is different one compared than other processes. Why I am saying means this technology only able to do the repairing products. Okay. So if suppose in a single product has some minor repair or maybe the breakage is available in that some places mean, on that case we can able to use this type of technology and easily repair that particular place or particular part by using this type of DED technology. Here also some of the metallic products are developed and the materials like titanium alloys, stainless steels, aluminum alloys and copper alloys also used in this DED technique. The last technique is sheet lamination. The laminated object manufacturing is the main process come under this sheet lamination technique. So here the working principle, the thin layer of sheets adding one by one. So finally we can get a bulk sheets as a single product. So wherever the part is required, we just limit the section and cut that section. So finally we can get a single product by using this type of additive manufacturing technology. Here also the materials like thin foils of aluminum, copper and some other stainless steel and titanium materials we have used in this type of sheet lamination technique. So overall these are all the major techniques we have used in this additive manufacturing technology. So nowadays this additive manufacturing technology is mainly used in many of the research oriented activities as well as many of the applications like biomedical and aeronautics, automobile and many of the applications we have used in this additive manufacturing technologies. It is emerging technology and it will satisfy the upcoming 5.0 and also the industry 4.0 in nowadays. So thank you. If you have any feedback, you just send a mail or call me. Thank you.